try to advocate Postgres use in the United States. One of the big things we do is we have a big US Postgres conference. We're having that in New York in April. Anybody interested along somewhere here, he has a bunch of cards, right? He's one of the organizers with me there in New York. If you're interested, he has cards about a little bit of details about the conference in New York. It's a lot of fun. I also help run the Philadelphia and the New York City Postgres users group, growing the local user group, not just the nationwide, but trying to do it locally at the city and trying to involve different things. And also, like Nikhil said, my day job is being the CTO of OpenSCG. So this is probably my third or fourth time here in Bangalore, 10, 15 times here in India. A lot of people don't know about Bangalore is that it has some interesting roots when it comes to Postgres, specifically around Enterprise DB. All these guys over here with the orange and black shirts. Back one of the first times I was here in Bangalore, we had a consulting company called Fusion Technologies, and we were doing a project for one of our customers that really inspired the early days of the Enterprise DB product. So if it wasn't for some of the folks here in Bangalore, things like Enterprise DB wouldn't be there, and in turn, a lot of the things going on in Postgres inside of India may never have happened. So it's kind of interesting that we're having these things here in Bangalore. Thinking back, this was more than 10 years ago, those early days of Enterprise DB. So it's great seeing a lot of familiar faces here. Got to know a lot of people here over the years, and it's great to be back. Hope to be back again in the future. So what is a federated database? Federated databases are a pretty old concept. They were, started 10 to 15 years ago. There were products around it, one called MetaMatrix that Red Hat bought. This is the long Wikipedia definition of it. Basically it is you have one database as a proxy in front of other databases, and the data stays at the remote database. And Postgres does that really well. And probably Postgres is really the only database that would ever be able to do something like that. A lot of that has to do with the commercial dependencies of other databases. Postgres has no real commercial ties. So it's okay to talk to Oracle or talk to MongoDB. There's no way that Oracle wants to talk to MongoDB unless they have to. So they're going to make it very difficult. Postgres wants to interact with everybody. It's an open community. You want to be able to get data from everywhere. So it's a natural fit to be able to fit this sort of role of being able to be that center of the data universe. And Postgres, like every other feature that it tries to do, it tries to follow a standard. So this sort of thing of being able to connect to remote databases actually comes from the ANSI standard called the SQL med spec. So it's not something that Postgres just kind of made up in order to do it. It actually follows some standard that's there. But really, Postgres is the only major database that follows that spec. So in essence, what happens is you have your users connecting to Postgres, and then Postgres will connect to all those remote databases, whether it's Oracle, MongoDB, Hadoop, any number of different things, and be able to return that back to the user. So really, Postgres is proxying the data for all those remote data sources. And then you can do interesting things like joining your Oracle stuff to your MongoDB stuff to your Hadoop stuff, all in a single query if you were crazy enough to do something like that. Right? So it's different use cases that you may have. One of it is distributed partitioning. So a lot of people use partitioning of being able to segment their data by date. One of the cool things you could do is have all your live data sitting there in Postgres and put all your old data, say you have a regulation that you have to keep your data for 7 years, move it off to Hadoop. Move it in there, and then if you have to query it, you'll be able to query the local stuff for your new data and Hadoop off your old data. So this way you could get it off your server and not have that impact any performance. By and large, most people use this for ETL in order to get your data in. We use it all the time for migrations. You want to migrate from Oracle, SQL Server, Sybase, pull it into Postgres. We're seeing a lot more MongoDB migrations as people start realizing MongoDB isn't all it's cracked up to be. And speaking of that, around business intelligence, MongoDB just released their new business intelligence connector a few months ago. And lo and behold, it's just Postgres with foreign data wrappers. Right? So in order for MongoDB to do anything with business intelligence, it needs Postgres. And then validation. If you have a bunch of different data sources, you want to assume data in your Oracle databases matches your Oracle, the data in a SQL Server database, you could use Postgres to run queries against both of them and see if there's any deltas between them. There's a bunch of different types of foreign data wrappers. I classify them into 5 different categories. One of them being SQL wrappers, others NoSQL wrappers, files, some sort of file format, miscellaneous because they're just no way to categorize them, just a whole bunch of weird different things. And then the Postgres one, which is kind of special because it really does everything you possibly could kind of do whatever Postgres does at its current version. It's kind of the unique one. SQL wrappers. These are kind of easier to understand. If you're coming from an Oracle world, this is like database links. So you can do a database link from one Oracle database to another. This allows you to do basically a database link from Postgres to the Sybase, or Postgres to Oracle, Postgres to SQL Server, or MySQL. And it's pretty straightforward where you bring in a SQL statement and it sends out a SQL statement and gets the results back and it proxies it through. So when you're doing it, you first load in your extension. So Postgres has extensions whenever you want to add additional functionality to the database. For the Oracle one, there's an Oracle FDW extension. You create extension Oracle FDW, and then you want to set up that connection. And that's where that DB server Oracle name, for Oracle people, that's their TNS names. You just put it in there, that's your connection information out to the database. And then you have to set up that user mapping. That's your security. What user are you connecting to that remote database as? Right? And so it's the ever-present Scott Tiger for all your quick examples inside of Oracle. And then you create your foreign table. So if you look, that's Postgres syntax that's in there. So if you were on Oracle, that department number is really a type number, and the other two are varchar 2s. But you're mapping it to what the equivalent is on Oracle. So it's an integer and varchar. And then you put down at the bottom of what the schema and the table is on the remote server. Fairly straightforward, you're just creating the table. And then when you do a select star from your Postgres pSQL prompt, right, lo and behold, it pulls the data from Oracle and shows it like it is on Postgres. Right? So this way you could connect your Postgres database to your Oracle database. Again, great for those Oracle migrations. When you want to get off of Oracle, great way to pull that data over really quickly. This is where they start getting a little interesting. NoSQL. The whole point of NoSQL is not to use SQL, and you access Postgres with SQL. Right? So it gets a little strange, and so that makes the foreign data wrappers a little bit more complicated to deal with. How do you relate something in, say, MongoDB that's a JSON document out to a table representation that is in Postgres? So it gets a little strange, right? And so the people maintaining those foreign data wrappers have to do that translation work for you. When you're using the foreign data wrappers, it doesn't really matter because the people that wrote the foreign data wrappers handled all that for you. So you can do anything from Hadoop to MongoDB to Cassandra. It's an ever-growing list. The more people come up with NoSQL databases, the more foreign data wrappers that are coming out. So for those of you that are familiar with MongoDB, this is really one of their sample data schemas. Right? You have collections, right, which I kind of equate to like tables. Right? And then you have, the zips thing inside the collection, right? And which has all the zip codes in the United States. So what's the code that maps to each town inside the United States? And it's a JSON document that has an ID, your city, your state, population, and it has the latitude and longitude as an array. Right? So that's their sample stuff that goes in there. Right? What are they able to access? Again, you create you add your extension, Mongo FDW, right? And then you create your foreign table. And here we again map it out to regular tables. But one of the cool things about Postgres is it has arrays. So that array that's in MongoDB actually maps down to a numeric array inside of Postgres. Right? So this way you're able to access that and access it the way you would normal Postgres in SQL. Right? So now you can do a select star in state of New Jersey. That's the state that myself and Robert Haas are both from. So you can see all the different towns inside of New Jersey. Some of them fairly small with only 7,500 people at it. Right? New Jersey is a densely populated state, but not as densely populated as Bangalore. Also, you have the ability to make these writable. Not all of the foreign data wrappers are writable. Things like the Hadoop one are. You can thank Nikhil for some of that stuff. He did that a couple years ago for us. So you could do create one out to a foreign table in a Hive server. Great way to use it as an audit table. A lot of times audits, every time you want to access something, gets very big, but you also want to get it off the Postgres server. Hadoop has a product called Flume that kind of ingests data quickly and then it gets it out to HDFS. So when you're creating your table, you could give it a Flume port of where to connect, and this way you could actually insert into that table, and that'll get pushed out to Hadoop automatically from inside of Postgres. So you can imagine you could put triggers or whatever you want on there as a easy way to set up some basic auditing and getting it off of the Postgres server, because a lot of time auditing requirements mean you can't have it on the same server. It has to be off that, because in case your DBA is doing something nefarious, you want to be able to get that off of that server, right? So this is one easy way of doing it. Doesn't always pass security audits, but it's a way to do it. Another one is the file wrappers. I end up using these things all the time for ETL. One of the really fun ones is the PG dump format. So when you do a PG dump, you use that little flag -FC to get the custom format, which is nice and compressed and gives you a lot of functionality in there. But if you ever have to pull out some of that data, you have to restore the whole thing back or even restore the whole table. The PG dump FDW, what it does is it actually reads and writes from that format. So if you only need 3 rows out of 3,000, you could just select them out of there without restoring that whole thing back and being able to use, get it out and then do all the stuff. And you just use it as a simple way to get the data out. Unfortunately, the history of that one is, it's not so fun. The folks over at MeetMe, one of the social networks in the United States, they get requests from police all the time in order to find child molesters, right? And they have to go back to the old backups in order to get evidence that they were interacting with young children, and it was a real problem restoring that all the time out those big databases. But hopefully people have a better use for that. It ends up being really useful. One of the things that you use all the time for is the file FDW in order to load data in. When you're doing some sort of ETL processing, a normal thing is to load it into a temp table and then process that as it's going in. So you end up moving the data twice. By using the file FDW, you could kind of read it from directly and transform it all in a single SQL statement. So I found some data that had all the international T20 matches going back over the last several years. Figured that was a fun one to work with. Loaded that in, and one of the strings in there was that it was India versus Pakistan with the VS in there. Right? So we wanted to split those things into 2 different columns. Right? And you could do that all through a single statement. So we insert it into the real matches table and do the ETL all through a single statement instead of loading it at a temp table and then doing it as a 2-step process. This is where the miscellaneous ones get kind of fun. And a lot of them started as just proof of concepts, just something for people to play with. You could have foreign data wrappers out to Twitter or MailChimp. S3 sometimes becomes useful. There's a couple in there that end up being pretty cool and pretty useful. The PG Strom one is a nice thing to be able to access GPU in order to be able to do that. I don't know how production ready it is, but it's a nice seeing it's going in that direction of being able to do that. But what we actually use all the time in production is CStore, which is a columnar store. And Robert's talk earlier talking about possibly bringing that sort of thing into the core, but it's there today as a foreign table. Right? And you're being able to leverage the ability of a columnar store already as a foreign table that's in there. So being able to leverage that, inside of that data that I found, it had the actual ball-by-ball statistics going back for all the international T20 matches for a while. So you imagine that's a lot of data. And it's insert only. You're not going to go back and change the data from a couple years ago. So you're always going to be appending to it. So it's actually ideal for a columnar store if you want to be able to query off of it. So you could create your foreign table onto that columnar store, right? And you just define the table the same way you would in Postgres. Right? And it also allows you to compress that data. Right? So one of the great things about foreign data wrappers, it allows us to experiment with different storage types without hacking the core and being able to do proof of concepts off of that pretty easily. So as we're seeing that this is really successful, this talk starts about bringing that inside a core. Right? It's a great way to get there quickly without being intrusive. One of the real fun ones is the www wrapper. It allows you to make a request out to a web service. Right? It's not that production useful unless you want to be able to access say, an internal web service for some sort of data validation. But it's just kind of fun and cool that you can make it so this way you could do Google searches through a SQL query. Right? And this SQL query is, show me everything that does a Postgres FDW off of Google. And that's essentially what that's setting it up to do. It really works against any sort of web service API. You can define it and be able to pull that data back. Don't make this as part of your regular application. Do this as sort of maintenance jobs in order to be able to validate some data. Just because you could do it in Postgres doesn't mean you should do it in Postgres, right? Postgres could do a lot of things. I've seen people do a lot of stupid things with Postgres. Don't do the stupid things of, just because it's cool and fun. So the Postgres FDW really is the most functional. It allows you to do a lot of things with Postgres, and it's really the proving ground for all the new functionality, and all the FDWs are now following it. It didn't come out until 9.3, even though foreign data wrappers came out in 9.1. And a lot of that was because you wanted Postgres to have, the Postgres FDW to be the premier foreign data wrapper for it. So it took a little while before we got it right. So again, this is same way of doing it. You have your FDW, you create your foreign data wrapper, and you give it the connection information. Here it's just localhost port, and the database name is Cricket. Right. And then you set our user mapping. This one says public, so this one is just everybody could kind of connect with the default configuration. Right. It's not the most secure thing, but for testing, it definitely works. Right. And then because everything's the same, we were connecting to another Postgres database, your table definition is essentially the same on your local and your remote server. So this is actually, when you do a query off of this, we're actually connecting to the CStore FDW one, so it's 2 levels of indirection. Right? So in order to see what these FDWs are and what they're doing, if you run a query, if you do an explain verbose, it actually tells you what query it's running on the remote server. You do explain verbose when we say, give me the batting team and the batsman for all the different balls on the remote side. You can see that it's doing a select, the batting team and the batsman from there. That's the query that it's sending across. Right? The nice thing about the Postgres FDW is it's only asking for the columns that it needs. Not all the FDWs do that. Some of them just do a select star and pull them all back and then process it on the Postgres side. The Postgres FDW is now just asking for what it actually needs. It also sends a where clause. Again, not all the FDWs send a where clause. Some of them just do select star from table and pull it all back and let Postgres figure it out. Postgres FDW actually does. So if you want to say all the batsmen from India, right, it sends it, and you can see it's doing a little transformation. Now we're putting some parentheses around there, and we're casting it to text on the remote side. Right? So Postgres, it's not just taking it and just handing it off. It's actually parsing it, figuring out what it should send to the remote side. It also sends in the built-in immutable functions. So if we wanted to see all the runs that Coley had, right, we're able to figure that out and based off the lower of it, right? Because the lower function is a built-in immutable function. This doesn't work with all your functions. This only works for the ones that are built into Postgres. So if you write your own function, it's not going to send it, right? But the built-in ones do. So this way, lower is a normal thing that you do when you're doing string processing of names. You don't know if somebody capitalized the letters or not. It's a normal thing, and then a lot of times in a remote database, you might have a functional index on the lower of the name in order to look it up quickly, right? So this will actually send that same lower across. It also is updatable, right? So when you do an update, so while I was looking at the data, one of the matches, it had a null for the city, and it ended up being that the city for that match was Sydney. So I wanted to go update that data. Right? So what happens when you do an explain verbose on that? Postgres is doing some interesting things here. The first thing it does, if you're used to reading explain plans, you read them from down up, right? So here, the first thing it's doing a select. It's pulling back all the columns, and it's also getting the CTID, and it's locking it. So the CTID is the physical representation of where that row is on disk, really what block and what slot number it's on there. And it's locking it so nobody else could change it. while it's on there. And then it'll take that and it'll use that CTID, which will be a very fast lookup because it knows where it is physically on disk, and do an update on that. So it's a two-step process when you're doing updates. So be aware that if you're going to use Postgres to do remote updates, it's actually you're doing two different queries. Right? It's got to lock it and then it's going to send the other update. So it's not the most efficient thing in order to do remote updates. They're also transactional. So if we were going to do this, so this is that match, the city was null, and then if I go ahead and do a begin and I run that update, inside of that transaction it says it's Sydney, right? It goes through as you'd expect. But if I roll it back, it goes back to null because Postgres is the remote writes are also transactional. Again, not all FDWs are like that. The Postgres one is. This is where you can do some of the distributed partitioning, right? Where you're able to have your data split out across multiple different servers. You could also use this for very simple sharding, right? Of being able to split your data across a bunch of different servers. So say we have created one partition called Postgres new, matches new, so everything from 2015 on forward, right? And then the match is old, so everything older than that, we want to move that to an older server. So we only have a limited amount of RAM, we're only going to access the latest matches most frequently, and we want to look at the older matches. It's okay if it's a little bit slower. So using Postgres' partitioning with table inheritance, the other table can be off of a foreign table. Right? And you can move all that off there. So you imagine when you're talking about billions of rows, you want to move all that out to something like Hadoop or some other big data type solution. That it's just going to sit there resident on cheap storage, right? And you can optimize for that. A lot of regulations, at least in the United States, mean you have to hold the data for 7 years. That doesn't mean you actually use that data for 7 years. Right? So archiving it becomes more of a problem. You imagine a lot of the financial services things on Wall Street, they get billions and billions of rows, and they're required to keep 7 years of data, but they really only need the last 3 months is for the most frequent stuff. So the rest of it, they can move off to another server or a completely different solution, however you like. And Postgres lets you do that pretty easily with the distributed partitioning. So when you run that, it'll get the foreign scan and also the local scan. It'll do both of them as it's doing the remote one. And we could create each individual table to be different, each individual partition to be a different format. So if we want to have your most recent month on the local server, the latest year on another Postgres database that's real close to it, and then anything older than a year we can move out to Hadoop. And that could all be the same individual table. Right? So it lets you do some interesting things with your data archiving policies. Also lets you do some basic sharding. If you wanted to be able to partition it by ID, you could have 5 or 10 Postgres servers, and you'd be able to read and write to all of them through the same thing, through basic partitioning. Right? You could do more complicated things with PL proxy and other types of solutions, PG shards. There's a bunch of them out there, but if you wanted to just do very simple sharding, you could do that with just built-in stuff with Postgres with just the table partitioning and the Postgres foreign data wrapper. Right? And it's nothing more complicated than that. It's not the most performant thing in the world, but it certainly works if you want to split your data across multiple servers. So as cool as foreign data wrappers are, there's a lot of limitations to it. Right? So you want to understand what those limitations are before you go running in and start using them all over the place. One of them is it doesn't push down aggregates. Right? A lot of times you want to use foreign data wrappers for reporting off of things. So if you want to select the sum of all the extras, right, off of what India had off all their T20s, right, you're able to do that. But what Postgres does is it returns back all the rows and all the extras, and then it does the sum. Right? So if there's a million rows in there, it's got to return back a million rows over the network and then sum them up, right? Which isn't the most efficient thing to do. Right? And you can imagine things like when you're dealing with big data, you've got billions and billions of rows. Sometimes you're going to have to pull back those billion rows, which end up being really, really slow. The way to get around a lot of these things until Postgres is able to implement it in core is create a view on your remote side. So if we had a view that did that select sum and then we just return that one row, that's a way to get around it very simply because you could do foreign tables to views as well. right? And that works on Oracle and Hadoop and Postgres. You know, if there are limitations, the easy workaround is creating a remote view and calling that remote view directly, right? So here it's not a big deal. There was about 1 million rows in there, right? Postgres could process those 1 million rows fairly quickly. If it was 1 billion, it'd definitely be a problem. Order by, group by limits are not sent down. Some of these will be fixed in future versions of Postgres. But again, the same sort of thing is if you wanted to be able to run this simple query of, you know, give me everything where all the matches that, the first 5 matches that India played, right? It has to return back everything there except for all the matches that India played, right? All of them get sent back over the network, and then Postgres has to internally go ahead and order them and then do the limit 5, right? So a lot of processes get done on the local machine, and you want to push it out to the remote. Again, this goes back down to some of the more big data ones. When you're dealing with things like parallel processing and Hadoop, you want a big Hadoop cluster doing your order by. You don't want a single Postgres instance doing your order by. And until some of the parallel query stuff gets in there and doing parallel sorts, you're going to be doing that in a single CPU. Whereas on your remote side, you have the ability to be running that off of 10,000 CPUs, right? So you want to be able to push some of that stuff remotely. And again, you know, a lot of times, a lot of projects we do this for customers is they have a big Hadoop cluster and we want to access it with Postgres. We're putting a remote view over there. So we're just calling the view. This pushes down all the parallel sorts and the parallel group bys onto the Hadoop cluster. And you're able to pull back just the rows you need and don't have to process the billions of rows on Postgres side in a single CPU. Joins are not pushed down, right? Again, we heard about this morning. When you want to be able to join 2 tables, Postgres has to pull them all back and then join them all locally, right? So if we want to join the matches in the matches info table, we got to get all the matches info back. We at least have a where clause on the matches table where the date is greater than 2015. So it's just pulling back those rows because it has a where clause, like right here, right? And then it'll join it there. But it's going to pull back all the match info stuff because it doesn't know what subset of rows it does unless you push down the join. The remote side knows what rows to return back. We don't know until we pull it all back and process it locally. So once we're able to push down remote joins, it'll reduce the amount of rows that have to come back because it has to pull back that entire match info table in order to process it. Every time you're pulling data over the network, it's going to get slow, right? So you want to do it as infrequently as possible. This one's kind of a fun one. Sometimes, because they look like a table, doesn't mean they actually act like a table. Again, like when you're connecting to Postgres, and a Postgres on the other side, you expect it to behave like a normal Postgres database. A lot of times you get lulled into a little bit of a problem because you're connecting to something that's not a relational database. You know, when you're connecting to an Oracle database, it's going to behave a lot more closely to Postgres. But when you're connecting to this one here, which is the www wrapper, connecting out to the Google's geocode API, it doesn't work like a table because it's not a table. It's really a web service that you're calling, right? We're just calling it with a SQL wrapper. So it looks like a table. It feels like a table. It doesn't act like a table, right? So this here, we have a table that has a bunch of sales leads in it, and in there we have addresses, right? And what you want to do is you want to be able to geocode those addresses, right? And if you just simply join those two together, you would think it would just kind of magically work. But when we do that, we get no rows back. Why is that? The first thing, again, you're reading kind of from the bottom up, the first thing it does is try to pull back all the data from the geocoder API, right? But there's no where clause, so there's nothing you're sending in. So if you go to Google, give me the geocode of nothing, it's going to return you back nothing. So Postgres doesn't have any rows to work with. Then joining to these 500 rows in this file, right? So joining 500 to 0, you get 0. Right? So it doesn't work the way you'd expect just because it looks like a table. You have to remember with foreign data wrappers, you're subject to what the remote source does. This is especially true with all the NoSQL databases. Just because we can make MongoDB look like a Postgres database doesn't mean it is. Right? So it's going to act like Mongo, it'll just look like Postgres. Right? So the way to get around something like this is you got to write a little bit of PLPG SQL code. right, in order to be able to have it behave a little bit more closely to what you'd expect. Right? So the first thing, you know logically what you'd want Postgres to do, even though it's not really capable of ever really doing that because the Google geocoder API is just not a table. First thing you do is give me all the leads, the sales leads, and give me their addresses. Right? So you want to get those first. You know we have those. And then one at a time, we want to join that to the geocoder API, and we're going to pass that in that address. So effectively, what you're doing is a nested loop join inside of PGDay in order to make this sort of join actually feel like a regular relational join. These are some of the things that Postgres does under the covers automatically for you. But when you're doing it to remote sources, you have to kind of do it yourself when it's not really dealing with a source that's rational. Right? And then what you do that, you get the thing back, and then what we're doing is we're creating the row, and then we're doing return next. So this is a set returning function, so when you call it, it looks like it's returning back just a simple join table for you. Right? So again, be aware that it doesn't always behave like a table, even though it looks like a table. I think the biggest limitation of the foreign data wrappers is the quality. Right? If you go to the Postgres wiki, there's dozens of foreign data wrappers there. You're not sure which ones are good, which ones are not, which ones do different features other than just trial and error. There's no certification for the foreign data wrappers. There's two of them in there. The Postgres FDW and the file FDW are built into Postgres core. They're part of the contrib modules. You could be sure of their quality. But all the rest of them, some of them might have just been somebody's side project they put up there. Some of it might be sponsored by a company. You have no idea. Right? So you have to do a lot of testing around those individual FDWs. You have to make sure that they're doing what you expect. And you want to look to make sure that they're actually being maintained. Right? Some of them are, some of them aren't. Some of them are read-only, some of them are writable. Right? There's no real quick way to tell over there. Maybe there's something we could do as a community in order to be able to do that, some sort of check mark we could give to it that it at least has these features and it has at least passes some regression test suite that we kind of like semi-bless. It's hard to do that as a community because really nobody really owns it, right? Somebody could just randomly come up and write a FDW, put it on the wiki, right? And then people might use it. That's part of the open source community of how you do things, right? But so be careful when you're using them. Just because there's an FDW there that connects to a source that you want to be able to connect to doesn't mean it's production ready. So go ahead and test that quite a bit. The other thing is a lot of them aren't built as part of any binary distribution. If you want to be able to use them, you're going to have to build them, right? And that means compiling that. So you don't have to compile all of Postgres, but you have to compile that foreign data wrapper for a lot of them. Some of them are part of some of the distributions, part of the Postgres Yum repository. Some of the Windows distributions have some of them in there, but not all of them do. Right? So if you want to be able to use kind of the Rethink DB foreign data wrapper, I don't know of any binaries out there for it. You have to go build it. Right? So that's one of the limitations. You have to include that in your testing plan of compiling it and seeing if they're going to actually have your updates for it and be able to compile it and distribute that out to all your applications. Right? So it's great that Postgres can be able to connect to all those foreign sources. But it's also terrible that we don't have any way to ensure that the quality is good of those things. So that's something that I think we need to work on as a community, is be able to have some sort of semi-certification, because certifying it is tough, but have something there in order to say it at least has all these features, right? And this way it at least passes some tests. And then you're actually maintaining updates for this. Because the FDW API, it's changing, it's evolving. The ones that worked in Postgres 9.2 don't work against Postgres 9.5. The API changed. So if they're not maintaining it, it may not work against the version of Postgres that you're using. But because of that, sometimes you just want to write a new one. Right? You have this new database internally that you're using. You might have been one of those crazy companies that wrote your own database. You want to be able to connect to it with Postgres. The black hole FDW is a great template to be able to start with. Right? If you're good at writing C code. right? If you're going to write C code, right, you have to fill in you have to create these functions, right? That's the minimum. The rest of these are optional. Those are if you want to make it writable and be able to pull back statistics. But you can write C code in order to make a foreign data wrapper of yourself. Easy way. If you want to be able to connect to really low latency performance is not a problem. Multi-core. It lets you be able to access things through simple Python code. So if you want to be able to experiment and foreign data wrappers out to something before you want to write all the C code, right, do that. So this gentleman here, Richard Ott, he was at the New York conference last year. He wrote a foreign data wrapper to be able to access the Philips Hue light bulbs. So as you insert a row into a table, it would turn on one of the light bulbs. And as you updated the values on it, it would change the colors. It's not very useful, but really cool. So just showing the simplicity of the multi-core. Instead of all that C code, this is the full iCal foreign data wrapper. It's just a little bit of Python code. Very simple to be able to access it and be able to start playing with it if you want to be able to start getting into that. Future, there's even more wrappers. Every time I look at the wiki page, there's more and more of them. We learned this morning, joins and sorts are on the way. And there's some talks right now about maybe using Postgres as its some future sharding stuff with FDWs, right? So we'll see where that goes. But it is something that is, every release of Postgres, there's more and more features of that inside the foreign data wrappers because it's a really great feature for Postgres in order to be able to access all that remote data without having to do full migrations. You could still keep all your data in the original data source and move things over to Postgres. So I think I got a couple minutes left.
Yep.
Cool.
Couple minutes left.
Okay.
Hi, Jim. Taking care of the limitations that you mentioned about FDW, if we pass the same SQL via DB-Link and via proposals FDW, would the performance match? Are they better, off, worse? How does that compare with the existing DB-Link?
Okay. Yeah, so what he asked is if you compare the performance of the old way of doing it with DB-Link versus doing it as foreign data wrapper, would they match? I would suspect it would be faster of doing it with the FDWs, but marginally, right, if you're sending the same query. I never did any testing on it in order to know, and I'm not aware of anybody doing the benchmarking. But this way you're not going through a separate function, you're doing it more inside the core of Postgres. It probably is marginally better as opposed to going through the function API, but that's just speculation.
Hi, my question is regarding the joins and the sorts. Why is it always difficult to push down the joins and sorts? Because most of the DBs, joins, maybe NoSQL databases, they don't provide joins. But sort is something that is available in almost all the DBs. So why is it difficult, or how difficult it is?
The question is, why is it difficult to push down joins and sorts? It's not overly difficult to be able to do that in order to do it in some cases. Joins, it's more on the planner level. Do you know that both things are on the same remote source? Sorts, you have to worry about what's the collation on the remote side versus the local side. Which sorts are you going to have when it comes back? It may or may not matter to you as you're doing it. So there's some, not necessarily technical issues of pushing it down. You have all that in order to be able to push it down at the right places in there. So there's some plumbing to do, but it's not rocket science or rewriting major amounts of code. It's more of how do we handle that with the remote sort, with specifically around collations. Matters in Postgres, but what happens when you're dealing with sorts on a remote side that doesn't have the concept of collations, right? They're just going to do it one way, and the sort may be different on how Postgres does versus how the remote side would do. Which one wins, right? So it's more those types of questions that we need to answer for how we do that. And a lot of times that's handled by the authors of the foreign data wrappers is really the way to handle a lot of that stuff.
You can take another question. Can we use these slaves which are being used as hot standby? Let's say reporting queries are hitting the hot standby. Can we still use? Let's say we create the foreign data wrappers on the master. Can we even use them on the slave?
Yeah, that's the creation of those foreign data wrappers. As long as the library itself, so the DLL or SO file are on the slave, sure, the metadata itself is transactional, written in the wall logs, and that gets replicated. So long as the libraries there allow you to work it, you can create one on the master and it's going to be there sitting for you on the slave. But the common mistake I see people do is just install the binaries on the master and they forget to install, say, the Oracle library on the slave, right? And then you get errors because the Oracle libraries aren't on the slave, they're just on the master. But that sort of thing does work.
Okay, so that's a wrap then.
Thanks, everybody.
Thanks,